Lesson 4.8, Compound Inequalities, using the words and or. Please take a moment to remind yourself of graphing an inequality. This is going to be really important for today's lesson. You can do that by checking out these 3 inequalities as part of our warm-up. You should be able to do this based on the stuff that we did in Chapter 3 and stuff that you did last year in Trans Math. Please take a moment to do that before revealing the answers. Please press pause now. Just a quick reminder for us, when we see the or equal to, we always know that's a closed circle because that would mean that 5 is included as part of the solution. When we don't see the or equal to, that's where we see the open circle, so that protects -2 and does not include it as a solution. Something that is often forgotten that I want to remind you all of right now is the variable. We always label the number line with a variable, so we know what variable that number line represents. When we talk about compound inequalities, it's important for us to understand what they are. Just like a compound word is 2 words that are put together, like class and room, come together to form classroom. A compound inequality is 2 or more inequalities that have been put together. Inequalities are put together in one of 2 ways, using one of the following words. We can use the word and, which would be an intersection of sets, or we can use the word or, which is a union of sets. So let's talk a little bit about those intersections and unions. Intersections of sets A and B. I included the word and here because that's the key word for these intersections, is the keyword and. The notation that we use is A intersection B. The intersection kind of looks like an N. This is the set of elements that are in both A and B. Kind of 2 ways that you can think about it. One of the ways that we can think about it is that it's the elements that they have in common. In math terms, we often say the overlap of the 2 sets. So we can see that pretty clearly in a Venn diagram. If we have 2 sets that are represented, A with our left oval and B with our right oval, the intersection is the overlap, the 2 parts that they have in common. So the elements that would be in both A and B would have to be found in this section of our Venn diagram. When we look at this with inequalities, which we're going to be doing today, when we're talking about compound inequalities, we're going to be primarily graphing the intersection of inequalities. Again, this is denoted with the keyword and. So there are really 2 basic steps to this. We graph the solution for each inequality separately. Since our final solution will go on the number line, I like to graph one of them above and then one of them below so I can easily see the overlap where I can graph my final solution on the number line. And then that's the overlap then that we graph, the overlap of the 2 on the number line. So an example of this would be to graph the solution to the compound inequality. X is less than or equal to 6 and X is greater than -4. For our purposes today, I'm actually going to identify these with 2 different colors so we can see the 2 different colors on our number line. So let's get a number line. Right away I'm going to label it X because I know that my number line is going to describe possible values for X. Let's start here. I know that X is less than or equal to 6. That tells me that I'm going to have some sort of a force field around 6, and I want the numbers that are less than 6. Here, since it does include the or equal to, I will use a closed circle at 6. To represent the green inequality where X is greater than -4, since there is no or equal to, I know that in this case we will be using an open circle around -4, and we would like the values that are larger than -4. So we can see the green portion, the second inequality, being represented right here. So we've got 1 above, 1 below, and I want the intersection or where these 2 things overlap. They overlap just right here to the right of -4, and then they both keep happening until the blue inequality stops at 6. So we can say the overlap is between -4 and 6. That's what we're going to be graphing on the line. But we have to be careful because -4 is actually not part of the overlap because it's technically not part of the green inequality. So we're just going to graph this right here. The solution is -4 is less than X is less than or equal to 6. We can write this interval out with a double inequality. Now let's talk a little bit about the second compound inequality, the union. The union of sets A and B. Here our keyword is or. So taking a look, the notation is A union B. The symbol for a union kind of looks like a U. Very creative. This is a set of elements that are in either A or B, and we have to consider the part where they could possibly be in both. This really just is all the elements combined together. We're combining 2 sets into one. On a Venn diagram, again, if we drew our Venn diagram of A and B, A union B would just be everything that we see here. It would be the parts that are just A, it would be the parts that are both, and the parts that are just B. So when we take a look at a number line, we start out really similarly if we want to graph the this should say union, not intersection. Let's go ahead and switch that. There we go, graphing the union of inequalities, which again is our keyword or, because it could be one or the other. We would start out by, again, graphing the solution for each inequality separately. Since our final solution will go on the number line, we'll graph one of them above the number line and one of them below. And then join the two separate graphs and just put them as one. So our example, we're going to graph the solution to the compound inequality, x greater than or equal to 2, or x is less than 8. So all of my x's could be here, or they could be here, or in fact they could be in both. For our purposes today, I'm just going to assign them a color. Get my number line, want to remember to label it, so I'll do that right away. I'm going to put the blue inequality above. Closed circle at 2, x is larger, so I'm shading to the right. My inequality for the green, or the second inequality, will be graphed below. An open circle at -8, since x is less than -8, I'm shading to the left. And I just combine these two graphs as one. In this case, they're two separate graphs, they don't even touch, but all the solutions are represented with the white rays. One of them where the endpoint is included, one of them where the endpoint is not included. Or excuse me, included and not included. Those are our two examples. We will talk a little bit more about this in class. In class, we are going to be discussing the following examples. You should check them out now. You don't have to work them all the way through, but maybe kind of start to think about them so that you are prepared with some questions. Save some room for tomorrow in class, and we'll see you then.